we are now ready to start. I'm just gonna check the attendance. If how many we have? 81 participants. So I think we should start. So good morning, everyone. I'm Chow. You can call me Chow. I'm also a teacher at the University of San Carlos and the husband of your teacher, Jency. Now, since part of your requirement is to do a design of a sample building similar to this one, I think this is the one that Jency gave you for the gravity design. And this morning, I'm going to discuss the seismic analysis and design for this example building. I know you have different dimensions, building dimensions, and perhaps different base. So I'm just gonna work on this sample dimensions. We have 2 bays for each direction along X and along Y. And then the spacing of the columns is 6 meters each. So uniform lang for simplicity. And then we have one-way slabs. Typical na slab, one-way. You have 3 by 6 ang atong size sa slab. And then we have an opening here just to simulate the location of the stairs. Let's go back to the foundation layout. So this is the typical foundation layout, assuming the property line is away from the building footprint. So we can utilize a concentric footings. So meaning the columns are on center of the footings. So the assumptions, some floor elevations, the top of footing is -1. It means that's negative. Pasabot na it's below the grade level or the ground floor level. So you have to excavate mga 1 meter. And then the grade level is assumed at 0 elevation. So this will be a reference. So the second floor level will be 3.5 meters above the ground level. And then the typical third floor and roof deck will be at 3 meters. Yung story height will be at 3 meters each. So you have plus 3.5 plus 3, you have 6.5, and plus 3, you have 9.5 for the roof deck. Let's go back to the second page. For the floor loads, these are our assumptions, no? Assuming this is a commercial space. Let me check. Commercial, where's the dead live load? No, there's no live load here. So assuming we have partitions and then we have ceramic tiles for the floor finishes. And then you also have to add kanang concrete topping if you're going to have tiles. So accounting for those weights, we have here a uniform weight of 2.5 kilopascal. By the way, the partitions, although ang layout sa partitions are linear, in practice, we normally consider it as uniformly distributed or distributed per area, just to simplify the analysis. But for the perimeter walls, so of course it's obvious na the perimeter walls are along the perimeter beams, so you can apply it as a line load instead of having it as a uniform area load. So we only consider in the area load the partition. So naghatag ko diri 2 values. 2.5 is if we don't consider the slab weight, and then 5.5 if we consider the slab weight. Then for the roof deck,
Excuse me, sir.
yes.
Sir, kanang napa daw nag-wait na people
Ay.
sa waiting. And sir, pwede
Admit
na
all.
i-record ang meeting, sir?
Yes, you can record that. Kinsa may kabalo. Can you do it on your end?
Dili bitaw ko ka kuan ani, sir.
It's also my first time to host a
Ay, naana daw,
Zoom
sir. Naana
meeting.
daw. Thank you, sir.
Nag-record na?
Yes, sir.
Sige. Ongoing recording. Okay, sige. Thank you. Because I'm used to Teams manggod na app, not the Zoom meeting. Sige. Just let me know ha if ever that there are still people na want to be admitted. Please feel free lang to let me know. Okay? So for the roof deck, of course you have to consider also the weight of the roof deck. We have usually ang roof deck, you have to account for the waterproofing. Kung ibutangan po ni Mugtas, you have also to account for that. So based on our assumption lang dire, I put 0.6 na kilopascal load, area load, without considering the self-weight of the slab. Now, if we consider the self-weight of the slab, assuming the weight, the thickness of the slab is 125 or 150, so you add 3 kilopascal, it will increase the area load to 3.6. That is considering the slab weight. For the perimeter wall, again, you consider na tong a wall in the typical floor, area load is only the partition, we did not include the perimeter wall. That's why we have to load it separately as a linear load along the perimeter. So you have 6 kilonewton per meter. And then sa roof deck, usually we have a parapet. Kalabanan na, it's 1 meter high or more, depending on the architectural design. So we just assumed 2 kilonewton per meter. For the stairs, of course, although we have an opening here, of course, kaya wala man tayo slab, but we have a stairs. You also have to consider the weight of the stairs. So along here, we have to add a load that is equivalent to 14 kilonewton per meter. So this is just a rough estimate of the dead weight of the stairs. I think akong assumption here is 200 millimeters na thickness, average thickness of the stairs. That's why I came up with this value. So initial dimensions, we have slab 125 beams. We have to look at the plan. Initial pa lang ning assumptions. By the way, in design the first thing you have to do is to assume mga initial sizes. And then once you go on with the design, you'll have to do some iterations, either to increase the size if it's insufficient or decrease the size if you think you can still reduce the size to make the design more economical. Of course, the initial sizes, you can determine that if you have more experience na. Columns, our initial assumptions is 40 by 40 or 400 by 400 millimeters. So when we do seismic analysis and design, the most important part is in determining the seismic mass. Okay, ang seismic is an inertial force. If you're familiar with the inertia equation, the Newtonian equation for inertia, it's the force is equal to mass times acceleration, di ba? So that's the basic na equation atong gamiton. So similar sa seismic design of buildings, we adopted that principle, the inertia na force from Newton. So part of that is you have to determine the mass, and then the acceleration is taken from the code based on the seismic na hazard na atong i-consider. And then we'll discuss later the code based seismic acceleration. So for the seismic mass, we have to consider the weight of the slab, self-weight. I'm talking about the self-weight or dead weight. And then the self-weight of the beams, the stairs, the permanent na partition loads. Ang partition, kung CHB, ang usual na to dito sa Pilipinas, we use CHB na partition. So you have to consider it as a permanent partition load. Now, ang kanang sa mga offices, usually ang partition load diha is kanang mga movable nga partition load. Then you have to consider it as live load, no? If it's movable. But it's not common to have a movable nga partition. So you have to consider the partition load. For the columns, ang usual nga practice is to consider, because the seismic load is applied per floor level, no? Example, second floor, third floor, roof deck. So ang imong seismic force, inertial force, is applied at that level. Now, to account for the weight of the column, ang normal ginagamit is you have to compute the weight of the column, 1/2 the height of the column above that floor level, and then 1/2 the column height of the column below that level pod. These are the initial sizes, by the way, no? I think na-discuss na nato. So for naming convention I use G, meaning girder, for beams that are connected to columns, because I'm going to design these beams to participate in resisting the lateral force coming from the seismic or the wind load. And then kaning B, we have the B1 na beam and B2 are designed only for gravity na loads. So kaning B1 and B2 are not designed or will not participate in the seismic na resistance. So only the G na beams or na girders and the columns. Let me show you a 3D model of the structure. So this is the 3D model. No? By the way, unsay ka ng software ang familiar mo? 3D software. Na familiar sa inyo, ha? Is it STAAD, ETABS? Hello? Anybody? Revit. No, Revit is a drafting software. It's for drafting. It's not for analysis, structural analysis and design. Wala ba mo na tudloan og STAAD or ETABS?
Wala dyan may katryan na, sir. Ang
Wala
more
ka
nagamit
try.
na software, sir, kay Revit o AutoCAD.
Revit and AutoCAD. So Revit and AutoCAD are for drafting, no? But for structural analysis, you have to learn how to use either ETABS. This one, I'm using RAM. RAM structural system, kay mas familiar man ko aning software, or you can use STAAD, ang commonly used here in the Philippines. Anyway, ang ato ang buhaton po diri is manual nga calculation for the seismic load. But for the analysis man good, normally if it's a 3D structure, we have to use a 3D software pod na structural software, kay it's difficult to calculate manually if it's inaning a building, three-dimensional na building. Although you can do it using katong mga portal frame methods na inyong nakatunan sa theory of structures na subject. But it will take time, no? It will take time because you have multiple frames man. So let's move now to the calculation of the seismic force. So this is a spreadsheet I have developed in manually calculating the seismic force. So again, let me just zoom in a little bit. Again, na-mention ako gaina that the seismic force is actually idealized as a force applied at each level. So if you look at this diagram, you can see here a multi-level na structure with seismic forces nga F1 to F10. So as you can see, the forces is actually increasing, no? As you go up, as you go higher, the force is expected to increase. So you have smaller F1 and a little bit larger F2, and then F10 is the largest na force. So I said idealized because ang actual gid nga seismic is, it's not actually a force, but it's a parang murag imaginary nga force atong gi-consider. Assuming nga ang building will displace, di ba, kung mo-displace ni mong building na ay lateral na displacement, the topmost floor of the building will have the largest na displacement. So in order to simulate that or to capture that displacement, we also considered a force on top of the building as the largest na force. So meaning increasing imong force so that the lateral displacement of the building will behave in a manner nga na the same sa actual nga performance or behavior sa building when there is an earthquake. This spreadsheet is, by the way, created based on the current NSCP 2015 code. And we have here some important parameters now when we consider earthquake. The first parameter that we have to consider is the occupancy category. No? So you have occupancy. This can be found in NSCP table 103-1. Occupancy is ano na siya, it depends on the seismic design category you're going to consider for your structure. For example, let's look at the note. I have here some notes. So, muna yung occupancy category na to. So, when you say occupancy category number 1, meaning these are for essential facilities. So, for example, sa essential facilities are hospitals, evacuation center. You also have public school buildings. Now, ang meaning ani nga when you design a building as an essential facility, you have to design it in such a way nga when there is an earthquake, when there is a strong earthquake, mga magnitude 6 pataas, ang imong essential facility will still be in operation or operational pa siya even after a strong earthquake, di ba? Kay ang hospital, you expect the hospital to be kuan pa kanang in operation pa siya when there is an earthquake. Kay unsa may mahitabo when there is a strong earthquake tapos daghan ang ma-injured. So of course, ang imong hospital kay ni na damage pod or na collapse. So walay kadaganan ang tao, di ba? So you have to consider that. Now, another occupancy category is kaning level 2 is these are for kaning hazardous na facilities. So for example, kanang mga mga planta, no? Or mga storage facility nga naay mga explosive or mga toxic na waste. So you have to consider that as a hazardous facility. So again, you don't want the hazardous facility to be severely damaged or even collapse during a strong earthquake. Otherwise, it will be chaotic kay basinya nga ay mga chemicals nga posible mo explode or posible mo create og further damage sa mga nakapalibot niya nga buildings. Ang third na level is the special occupancy. Special occupancy structures, these are for single-story nga school buildings. Kanang typical nga school building nato sa elementary, no? Especially sa province, common na ang mga single-story nga school buildings. So those are part of the special occupancy. What else do we have here? Buildings with an assembly room and occupant capacity of 1,000 or more, or it could be educational buildings such as museum, libraries, auditorium with a capacity of 300 or more nga students, and so on. So those are special occupancy nga structures. Ang fourth level is the standard occupancy. So according to the definition of the code, so kaning standard occupancy are all structures housing occupancies or having functions not listed in category 1, 2, and 3 na category, or 5, category 5. So for example, kanang ato ang condominium, apartment buildings, commercial buildings, kanang common na to makita sa syudad, malls. So those are considered as ang malls is it could be more than siguro more than 1,000 institution. No, dili day part ng mall kay assembly man din ibutang. So malls, condominiums, office space, diha sa IT park. So those are standard occupancy nga structures. And then ang fifth nga level or fifth category is the miscellaneous structures. So usually kaning miscellaneous structures are those that are not occupied or kanang walay tao. For example, garage, wala may nagpuyo diha. So whenever ma-damage ang garage or mo-collapse, wala ray problema kay wala may tao nga posible maapektuhan. Or it could be sheds, or it could be kanang mga kanang mga poultry house. It could be a miscellaneous, no, kay mga manok na may naa diha. Now ang next nga parameter, seismic design parameter, is what we call the soil profile type. So ang soil profile type mao ni ang pag-determine on the classification of soil where you're going to construct your building. So there are 6 categories here listed in the code. Just gonna zoom in a little bit. So we have SA, SB up to SF na category or profile type. Now SA is defined as hard rock. Now in order to determine kaning hard rock, you need to have either of the two. No? So you need to determine the shear wave velocity, or if you don't have the shear wave velocity, wala you provide sa geotech engineer, then you can use the standard penetration resistance or the standard kanang SPT, number of blows na to. I don't know if you're familiar with this sa inyong geotech, but kanidang soil profile type, usually ang muhatag ani is the geotechnical engineer of the project. But for kanang mga 1-story building lang or 2-story buildings nga dili mag-require og geotech report, normally it's the structural engineer who will decide, no, depending on on-site nga inspection kung unsay actual nga naa didto. Ang second profile type, SB, that's for rock. So ang iyahang category dire is ang description aning rock is if you have a shear wave velocity of 760 to 1,500 meters per second. Ang katong hard rock, that's more than 1,500 meters per second na shear wave velocity. But the standard penetration, usually kaning hard rock o rock, ang SPT blows usually is more than 50. And kanang more than 50 is mura na siya kanang refusal na nga stage, meaning dili na mo penetrate ang imuhang SPT nga equipment. And then we have SC. This is very dense soil and soft na rock. So ang imong parameter nga i-consider ani for the shear wave is 360 to 760 meters per second na shear wave. Or if you don't have the shear wave na data, you can consider the SPT blows, which is 50 ang imong limit. So if the SPT blows is 50, then you can consider your subsurface soil as very dense na soil. And then ang fourth is SD. So ang common na ginagamit if you don't have any geotechnical report, usually ang atong gamiton is SD. But you have to do sample testing kanang pit sample. Magpakalot ka dito sa site para ma-determine nimo kung unsa nga klase ang yuta, if it's silty, clayey, sandy, or gravel or limestone. But mo ni ang usual nga ginagamit. So it's a stiff, ang description is a stiff soil profile. The shear wave velocity is between 180 to 360 meters per second. And then the SPT blows is in between 5 and 50 number of blows. Ang fifth nga profile type is soft soil profile. The shear wave velocity is 180, less than 180 meters per second. And then I think there's a typo error here. May typo error. Ang kanidang SD, it's 15 to 50. Ang kaning soft is, ang SPT na to is 15. And then ang last nga profile type is SF. So kaning SF, this is very soft. I think this is liquefiable siguro nga soil. And this one, it requires a site-specific na evaluation. So this will be another expertise which is beyond the scope of the structural engineer. Okay, let's move on to the next seismic design parameter. We have the seismic zone factor nga Z. So as of now, our code is using the zone map. So the Philippines is just divided into two zones. Na atay zone 2, in which the peak ground acceleration is considered as 0.2 G. G is the gravitational acceleration, ang 9.81 meters per second squared. And then the rest of the Philippines is zone 4. So ang zone 4, ang maximum considered PGA or peak ground acceleration kung na ay earthquake is 0.4 G. Let me check sa spreadsheet if I have the map. I think I have. I don't have the map, but if this is the Philippines, ang kaning western part, you have Palawan province or Palawan islands, group of islands, and then kaning parts sa Zamboanga here sa Mindanao, western part sa Mindanao, and Tawi-Tawi, Basilan, Sulunga Islands. These are considered or gimap ni sa ASEP or sa NSCP as 0.2G or zone 2. And then the rest, ang Luzon, Metro Manila, Cebu, Bohol, Negros, o kaning Panay Island, kaning sa Iloilo, and then the rest of Mindanao, except for Zamboanga, are categorized as zone 4 or 0.4G ang ato ang PGA. So Cebu City, obviously, we are located at zone 4. And then next, seismic design parameter is the seismic source type. Okay, so seismic source type, this is to identify the possible maximum magnitude of the seismic source. So normally, ang seismic source atong i-consider are the fault lines. Pwede po volcano if you are near a volcano like in Albay, na dool sa Mount Mayon, or in Taal volcano. But typically, kung diri lang sa Cebu, sa Bohol, or the Central Visayas region, we consider the fault lines as the seismic source. So we have three types for seismic source. We have A, B, and C. So for type A, ang category ani niya is for fault lines that is capable of producing a magnitude of 7 and up, no? 7 pataas. And then ang source type B, these are faults that may or can produce a magnitude, earthquake magnitude between 6.5 to 7. And then ang category C or source type C, this is a fault or a seismic source that is capable of producing less than 6.5 magnitude ng earthquake. Now, how do we determine kung unsa siyang magnitude? For now, we don't have the guidelines sa NECP, but we can always consult PHIVOX. Now, if you don't have, if you cannot consult PHIVOX, ang usual natong ang gina-consider is to have a conservative assumption. That is to consider type A. So conservative na lang, meaning safe na side. No? When I say conservative assumption is you assume on the safer side. So pwede na ito i-assume as category A. But ang kanila yung magnitude according to PHIVOX is dependent ni siya sa length of the fault line, no, kung pila ka kilometers. And the next parameter is the distance, the closest distance to the seismic source. So you have to determine the exact location of your building, tapos i-determine mo pilay distance of that building to the fault. So how do we identify this one? Now, ang PHIVOX, they have what we call the fault finder nga app. You can download it sa cellphone ninyo. Just type the fault finder app, or you can use the browser. Just type fault finder, tapos it will lead you to this GIS nga map. So what we're going to do next is to locate. For example, Cebu City ang ato ang building. So let's go to other fault systems. Just click agree. You can either zoom in sa map and double click on the area, or you can also choose based on location. For example, let's do it first. Cebu, and then go. Let's go to Cebu City. Cebu City. Cebu City, then go. For example, sa San Carlos, Talamban. And then go. But kaning Talamban is, yung i-consider is kaning Silver Hills. So gusto na ako ang exact location, which is ang Talamban campus. So kung i-zoom in mo, I think ma-identify man nato easily no as ang Talamban campus. So this is USC Forest Park. I think this is the Bunzel Building, College of Engineering. So for example, I want to build a new structure dito sa my soccer field. So ako lang na i-double click. And then the app will give you the distance of this exact location to the nearest fault. So ang nearest fault nato is the Cebu Fault System or CFS. This is Central Cebu Fault. The distance is approximately 3.2 kilometers. So dool day kayo ning TC sa kuan sa fault line. I have a conversation with PHIVOX before. No, nga kaning fault line, just gonna delete that one or close. If you look at the fault line, you have a north segment of this fault line, and then you have the south segment. So in between, murag na ay blind fault. So according to PHIVOX, there is a possibility that this fault line is actually continuous. No? So naanay fault line dire, but as of now, dili pa nila makita because there's no evidence pa man. No? Maybe underneath the surface is naani blind fault. So according to them, conservatively, we have to assume that this fault line is continuous. So if you consider the length of the fault from here or even here down south, so that's how many kilometers? So taas ka na, if this is 3.2, probably more than 50 kilometers na stretch. So according to PHIVOX, based on my previous conversation, if you consider that to be continuous, that will qualify as a type A daw nga, type A nga seismic source. So meaning it can produce greater than magnitude 7 earthquake. So that's why ato lang i-consider here na type A. And then the distance, it's not 10 kilometers but it's less than 5 kilometers kay ang atong na-identify is 3.2 kilometers man to. So less than 5 kilometers. And then ang next parameter is the height of the structure. Ang atong height is 10.5 considering at least stories ang atong building. This one. Ang next seismic design category or seismic design parameter is the resisting system nga gamito nato. So we have different systems. We have the special moment frame. We have a shear wall na system. But for this exercise, we're just going to consider a special moment frame. Ang special moment frame is composed of beams and columns, which is detailed so that it can resist seismic force in a ductile nga manner, meaning kanang makaresist siya og seismic force without kanang abrupt bitaw nga damage or abrupt nga collapse. So meaning ang imuhang frame is it has the ability to yield. Now, if you're going to select SMRF, we have to consider the seismic response modification coefficient or kaning R na to nga coefficient. So according to the code, if the system is designed as SMRF or special moment frame, the R for that is 8.5 and then the overstrength factor omega is 2.8. Next parameter is the period coefficient. Now, it's important nga we consider the period sa atong coefficient because the building period is importante ni siya in determining the seismic force. Now, ang code, since kuan man na siya kanang simplified. So, instead of doing dynamic nga analysis, 3D dynamic analysis, we can compute the period using empirical lang equation. And that empirical equation, you need an input for the period coefficient. So let's look at the notes. So ang code naghatag siya og different or 3 types of coefficients. For steel moment resisting frame, the coefficient is 0.0853. For a reinforced concrete moment resisting frame or SMRF, you have 0.0731. And then for all other building systems, so kung mogamit kag shear walls or dual systems or kanang BRB nga mga systems for high-rise nga buildings, you should use 0.0488. So sa atong case, we're using SMRF, so ang atong i-select is 0731. So ako lang ning gibuwag ang X direction o Y direction kay posible man nga if you are designing a tall building, posible man nga ang direction sa Y is different from the system you're going to use sa X. It could be nga ang X SMRF, it could be ang Y is shear wall or it could be a dual system. Shear wall plus moment frame nga combination. Ang kaning TB, this is a period using a more detailed nga calculation. I'm gonna input here 0 lang because I don't want to compute. I don't want to compute the dynamic na period. I just need to compute lang the approximate nga period based on the code, the simplified one. Oops. Wait, I divide mag 0. Any questions so far before na ma-proceed? Let's look at the chat. Wala. May pangutana? Sige, so if wala, let's proceed. There is another factors nga consider. So, after we determine the parameters, katong occupancy category, soil profile type, up to the distance, o kaning seismic source type, we can now determine the the seismic coefficients. So, ang first is the importance factor. So, kaning importance factor, this is related to the occupancy category. So, for example, akong building is essential, so category 1, the importance factor is 1.5. No? Or importance factor or safety factor. So, mas dako ang safety factor akong gamiton because I want the essential building to be still operational even after a strong magnitude ng earthquake. If it's category 2, it should be 1.25. And then for special, standard, or miscellaneous, the importance factor is just 1. I'm just gonna go back to category 4. Now, ang next nga parameter is ma-determine nato ang near source factor NA and near source factor nga NV. So kaning near force factor, this is important to determine the seismic coefficient nga CA and CV. So this one are the pag-compute na sa seismic acceleration. Remember, I said earlier na ang basic equation atong gamiton is the inertial or inertia force according to Newton, which is equal to ang force is equal to mass times acceleration. So we are now computing the acceleration part. So NA, this can be determined in NSEP. So you have to go to table 208-4. Ang pag-determine sa NA is based on the seismic source type. So earlier we identified nga it's type A, and then the distance is so the distance is less than 5 kilometers. So type A, then less than 5 kilometers. So I have to use NA value of 1.2. Let's go to NV. So this is another near source factor. Type A, again, we're using type A, and then the closest distance is less than 5 kilometers. So according to the table in NSEP, the NV factor is 1.6. Right it. So ang next ma-compute na to are the seismic coefficient CA and CV. So ang CA and CV are relative to NA and NV and also to the soil profile type. What's my assumption na to first? So we assume that the soil profile type is SD. And then the seismic zone, since we considered Cebu City, it's zone 4, meaning 0.4 G ang atong assumption. So ato lang nang i-match SD and 0.4. So we have 0.44 multiplied by the value of NA. So 0.44 times 1.2, that's 0.53 ang atong CA, ang coefficient. And then the next seismic coefficient is the CV. So CV, again, SD ang atong soil profile type and seismic zone 4. So the value of CV is 0.64 multiplied with NV. So 0.64 times 1.6, that's 1.2. So this is the acceleration part, no? To determine the coefficients and the factors to calculate the acceleration. Now let's go for the weight. So for the weight, as discussed earlier, the seismic weight or seismic mass should include the self-weight of the slab, beam, stairs, permanent partition load, and then for each level, you should consider 1/2 the column above that level and 1/2 column below that level. Now, for the slab weight, we can easily calculate the seismic mass. Kaya naman tayo i-consider during area load. So just have to multiply this area load with the area. So makuha din mo ang weight. For the roof deck, 3.6 times the area, kuha mo ang self weight. But for the members, again, dali naman po tingali because you just have to determine the length of the beams, multiply nimo with the unit weight of the concrete. That's 23.5 kilonewton per cubic meter. So you have the length and you have the initial dimension. So you can also easily calculate the seismic mass. So you can do it manually or you can do it using a 3D model. No? So the 3D model will calculate the seismic mass for you. Let's look at the... So I'm just gonna get the value since this is just a sample building from my analysis. Process, analyze. Reports. So according to my 3D model, ang akong seismic weight or seismic mass, by the way, don't be confused with weight and mass. Ang seismic mass, that's the technical term, but since we are calculating for the force in terms of kilonewton, ang atong i-input is still in kilonewton nga value. So at level 3, that's the roof deck, the seismic mass or seismic weight is 938.34 kilonewton. For the third floor, which is level 2 sa akong structure, that's 1467.84. Ang second floor level is the same with my third floor level, so 1493.25. So I now have the mass, and then I now have the parameters to calculate the acceleration. So I can now compute the seismic forces for each level sa akong structure. So naa lang tayo tulog ka levels here. So second floor, level 1, third floor, level 2, then roof deck is level 3. This is summation of the building weight from roof deck down to second floor. So that's about 3,900 kilonewtons. Now, ang next computation So nanatay mass or weight, then nanatay coefficient. Ang next na computation is to determine the fundamental period of the building. So we have the period coefficient. Earlier we identified nga SMRF pa na itong building, ang system gamiton, then it's 0.0731 na coefficient. And then the height of the structure, it's 10.5, assuming ang ako ang base is the top of the footing. And then for method A, just gonna ignore this. So the equation for the fundamental period, the simplified computation of the fundamental period of the building is kaning equation. That's according to equation 208-8 of NSCP. So the fundamental period in terms of seconds is calculated as CT. This is the period coefficient na itong i-determine gaina as 0.0731. And then you multiply that with the height of the structure na 10.5. And then the height of the structure is raised to the power of 3/4 or 0.75. So you come up with this value ng 0.426 ang fundamental period. Again, we will ignore the fundamental period based on dynamic kaning method B. So we're just going to use the method A. So 0.426 seconds ang atong period. Ang next na step is to calculate for the seismic base shear. So let's go back again to the R coefficient we identified as SMRF ang atong system. So you have 8.5 for both direction, no? X and Y. And then ang next na step is to calculate the base shear. So the base shear, mao na ni katong force according to Newton nga formula, katong mass times acceleration. So according to the code, there are the base shear is calculated as kaning equation 208-4, but you have to satisfy the limits, ang minimum and the maximum limits. So ang base shear is calculated as CV, i-multiply nimo og importance factor, and then i-divide nimo sa response modification coefficient R o sa period nga T. So CV times I divided by R times T. So this is the acceleration. So wa pa na ko i-multiply ang mass diri. So this is the acceleration part. So this one nga acceleration should not be below the minimum requirement according to this equation kaning 208-7. So that equation is 0.8 times Z, katong zone factor na to nga 0.4 for zone 4, and then multiplied by NV, and then multiplied by the importance factor divided by R. So you can look at this in NSCP lang nga code. Anyway, at the end of this lecture, I'm going to give you a PDF version of this spreadsheet as a guide. And then next is to compare the acceleration according to this limit na pod. So this acceleration should not be minimum or should not be below the minimum according to equation 208-6. So the equation is 0.11 times CA. CA is the value we calculated earlier, ang seismic coefficient, na 0.53. Multiply that with the importance factor. So if na ay minimum requirement, there's also a maximum requirement. So according to 208-5 nga equation, the acceleration that we calculated earlier based on equation 208-4 should not exceed. No? Kaya naman tayo max limit. So dapat di siya mo exceed. Sa kaning 2.5 times CA times importance factor over R nga equation. So kung atong evaluate 0.283, it's above the minimum. So okay. No, kaya ang minimum na to is 0.06 o 0.058 man. But it's above the maximum. Ang maximum is 0.155 and then ang atong acceleration na calculate is 0.283. So meaning we have to use the maximum limit na 0.155. So dili ta pwede mo go beyond sa limit. So this is the acceleration na, and then we have to calculate the base shear or the force na i-apply sa structure. And that base shear is simply the product of your acceleration nga 0.155 G or rather 0.155 na ni siya. I think this comes with G naman tingali. Yep, it's with G. So 0.155 times the seismic mass, total seismic mass or weight. So the total force or base shear is 605.56. So ang next na step, since na-determine na to ang design base shear, ang kaning design base shear actually is, by the way, is the total force, the total seismic force on the structure based on the seismic parameters nga itong i-consider. Now, ang next step is to distribute this force per level. No? So, going back to this figure, ang atong base shear should be distributed per level in a manner nga ang atong distribution is increasing as you go up. And you can do that using this equation, this one. Weight times height by the way, this one there. So this equation. So first nga atong buhaton is to compute for the additional force at the top sa roof deck. And based on the calculation, we don't have any additional force. So zero lang imong additional force at the roof deck. So to distribute the force per level, you have to multiply the base shear, the total force, multiply it with the weight per level times the height of that level relative to your base, which is the top of the footing, and divided by the summation of the weight times the height. And then you will have this force distribution. So we have 148 for level 1, 242 for level 2, 216. Well, ang kaning sa level 3 dapat mas dako ni sa level 2, but since we don't have additional force, walay na-calculate ng additional force according to this equation 208-14, i-come up siya nga mas lesser than the level 2 gamay. No? There's a small discrepancy. So this is now the force that we have to apply at each level of your structure. So you have to apply it by direction man. So this is for the X direction. Ang next is for the Y direction. This one. So if we go to the building structure, building story shear, applied story forces. So it will look like this. If i-model ni mo na sa 3D model, so your seismic force is applied, although ang value diri different, no? I think di consider ni ang katong different ka period. So these are the forces. So you have 1, 2, 3 sa level 1, 201 sa level 2, then 180 sa level 3. Now, sa 3D software, ang kaning force nimo per level, ang pag-distribute niya each frame is automated na. Now, in my model, I considered a rigid diaphragm, meaning ang akong diaphragm will not deform. So kung move akong diaphragm, laterally move akong diaphragm, ang movement sa akong column, now individual nga columns will be consistent with the diaphragm nga movement. So wala siya deformation. Now, to distribute the force for each frame, kung rigid ang imong assumption sa diaphragm, it will be based on the rigidity of the columns or rigidity of the frames, I mean, or stiffness of the frames. Now, if the diaphragm is not rigid, for example, flexible, imong diaphragm, usually flexible kung ang imong diaphragm is made of kanang light nga material. For example, kanang steel deck lang, walay concrete. So you can consider it as flexible nga diaphragm. Then the distribution will change. Instead of relative to stiffness of each frame, it will be based on tributary area of each frame. No, so kung sa atong model is 6 by 6 man eh, or 6 meters ang atong spacing. So if based on tributary area, kung flexible imong diaphragm, then 25% will go to the frame sa left, and then another 25 will go to the frame sa right, and then 50% will go to the frame sa middle. That is based on tributary area assumption. But if it's a rigid diaphragm, you cannot say that. It will be based on relative stiffness of the frame. Now, in our model, we assume the same sizes man pud sa columns and the beams. So, relatively speaking, the stiffness of each frame are the same. So, pwede ka mangingon nga 1/3 of the seismic force will go to the left ng frame, and then 1/3 will go to the right, and then the other third will go to the middle na frame. So the same goes with the Y direction. So this one is for the X. Unsay lang, excuse me, I'm gonna ask your teacher unsay inyong output. Hello. So according to your teacher, one of your output is to compute the seismic forces similar to what I did here. So you have to input the occupancy category and all the other parameters, tapos seismic weight, and then you have to come up with this distribution of the forces. So para madali lang sa inyo ha, I'm gonna print this one to PDF. I'm not going to give you the Excel nga file mismo kay para dili ma-copy paste. So PDF file lang akong ihatag, and then this will serve as a guide, no, for you to create your own spreadsheet. Chance? Ako lang din na mag-create ng spreadsheet.
Hello? Hello, good afternoon, good noon. So I will just post an announcement in the canvas of what you will be when and what spreadsheet will be the when and what spreadsheet will you submit for your next kanang output. So I'm just gonna announce it there kanang when, and you just have to make your own based on the katong inyuhang floor plan nga individual man mo og kaning dimensions. So I expect different results also from that. So do you have more questions? Any more questions before we end?
Miss, can I ask,
Yes.
like, where do we submit it? Because for the last requirement, the
Sa-
submission button was still not in Canvas.
How do you submit your kuan mga modules
Usually, Miss,
in other subjects?
we usually submit it in Canvas, Miss.
So sa Canvas pod, dili day ma-submit ninyo sa Canvas?
For the
output?
last requirement, Miss, kato the beams and slabs, there wasn't any assignment. Like, it wasn't posted as an assignment in Canvas. So I think a lot just submitted via email.
Okay. So, but you can submit it through assignment, as an assignment? in the
Yes, Miss.
Canvas?
If you make an assignment section for the
Okay. Sige, I will make na lang and then try to submit it there. Ha? So that
Okay,
mas,
Miss.
so katong mga I will also make na lang another kanang folder sa katong first assignment, first project, so that katong mga ni-submit through email, can you resubmit it there para mausa lang na ako og kuan, ha? Check.
Thank you, Miss.
Okay, thank you. Sige, are there any more questions? Okay, so I think that's it for today. Thank you for listening, and may you all have a good day.